inverse function. And as I already mentioned, it must be a one-to-one function. And the first part about this is just getting you to investigate these two functions, f and g. And you might look at these and notice that numbers are repeating, and you might also notice that the operations are fairly similar. So starting with f of 5. So with f of 5, as a reminder, because we've done problems like this, that's saying that x equals 5, and we go to the f function. So go to the f function, and we're going to replace x with 5. And I'm going to do some of this in my head, such as like 3 times 5 is 15. Maybe I'll write that out. I got 15 by doing 3 times 5. And 15 plus 7 is 22. Divided by 2 gives me 11. And before doing anything else, I'm just going to follow the directions and find g of 11. So as a reminder, this is saying that x equals 11 for the g function. So as I do that problem, again, I'm going to do some of this in my head. 2 times 11 is 22. Again, you might notice that some numbers are popping up, 22, 22. 22 minus 7 is 15. Divided by 3 gives me 5. So again, as you're working through this or you're following along, because you can copy this down after the recording, is you might notice some things keep happening. Well, let's see if some things that keep happening continue to happen for f of 0. So as a reminder, this is saying that x equals 0 for the f function. There's a reason why I'm color coding it this way. So 3 times 0 is 0. And I'm actually just going to leave this as 7 halves. You might notice why I'm leaving it as 7 halves. And then I'm going to do g of 7 halves. So as a reminder, this is saying that x equals 7 halves for the g function. Well, 2 times 7 is 14, divided by 2 is 7. So I have 7 minus 7 divided by 3. Well, 7 minus 7 is 0, and 0 divided by 3 is still 0. And I hope what you're starting to notice is as we do these problems, we keep getting the other's answer. I don't know if you noticed that. Like f of 5 gave me 11 over here. And g of 11 gave me 5 over here. So as we start working through the next one, in case you forgot how to do this when we took the quiz, we did g of -1 first. So that's inside the parentheses. So go to the g function and replace that x with -1. Well, 2 times -1 is -2. -2 minus 7 is -9. Divided by 3 gives me -3. So what that tells me is now we're going to do, because g of -1 equals -3, we're going to do f of -3. This thing replaces what was inside the parentheses. So now we go to the f function and replace that x with -3. Well, 3 times -3 is -9. Plus 7 is -2. Divided by 2 gives me -1. The whole premise of this is basically if these two things are inverses, and I'm telling you right now that they are, then what will happen is the composition, that's what f of g is. I'm just going to write comp. Then the composition will cancel. And that's why in part A, f of g gave me 11, and g of 11 gave me 5. And f of 0 gave me 7 halves, and g of 7 halves gave me 0. And that's what's going to happen. So as I move to letter D, you might be making a conjecture. You might be thinking, okay, well, if this is really true, I should get an answer of exactly 5. Well, let's see. Let's see, I haven't used orange yet. Let's start by doing g of 5. What's inside the parentheses? Well, 2 times 5 is 10. And then -7 is 3. 3 divided by 3 is 1. And then what I have to do next is f of 1. So 3 times 1 is 3 plus 7. I wrote down the wrong number. 10 divided by 2 is 5. We got exactly what we predicted. Again, this only works if they are inverses. So without doing any math, and your teacher just told you that f and g are inverses of each other, then they should cancel each other out. It doesn't look like it says cancel right there. So this answer is just going to be pi. And the directions here actually tell you that if they're inverses, they undo each other. I really don't have any other way of saying it besides like they cancel each other out. And here's I like the picture. I know this picture can be confusing, but I think it does a good job of explaining that when you plug in a value, let's say A for F, it'll give you some number. And then if you were to plug that in for G, some other function, if they're inverses, it'll just go back to the original problem. Sometimes how I phrase this is that the domain, now remember the domain, in case you forgot this from the quiz, is the X value, and the range, which is the Y values, switch. And I'm not trying to make this sound super easy because it does get complicated. So as I'm looking at exercise 2, so if the point -3, 5, so -3 is the X coordinate, 5 is the Y coordinate, is on some graph, which of the following must lie on the graph of its inverse? So since X and Y switch, sometimes I just have students write out the ordered pair, -3, 5. So the -3 needs to become the Y coordinate, and the 5 needs to become the X coordinate. So as you look through the options, the correct answer is option 3. Oops. So just as a heads up, as we move forward, we also have what's called inverse notation. So I know it's new information for you guys, but instead of having some different function, just calling everything F and G or H, we've seen a few of those. What we do is we want the reader to know that this is the inverse of the F function. So what we can do is just write it like F to the -1 power of X. And there's a reason why we use this notation. You don't really need to know it. If anybody's curious, you can reach out to me after this. But again, what I like to do, you don't have to do it my way. You could watch the author's video and see if you prefer his way of doing this. But they give you the graph. And what you can do is you can actually just write out all the ordered pairs. So I'm assuming I counted this correctly earlier, -6, -6. This ordered pair was -3, -4. This ordered pair was 0, -2. This ordered pair was 3, 0. And then this ordered pair over here is 6, 2. And what I'm just trying to show you is you can still just switch X and Y. Well, this first one's actually kind of meaningless. If you switch X and Y, it's the same ordered pair. But if you look at this one and you switch X and Y, then you get the ordered pair -4, -3. -4, -3. And if I switch the next one, -2, 0. If I switch the next one, we get 0, 3. And it actually makes the problem pretty easy to understand. And I do need to be careful about how I phrase that, but all I'm doing is switching things. And when I connect these dots, Now, I think it's easier, and again, this is my opinion, to answer these questions like what's F inverse of, well, now this is the X coordinate of that orange line I just drew. And so as I look at the X coordinate of the line I just drew, let me highlight for you. I want that value, which is 6. So F inverse of 2 is equal to 6. Right? Same thing with the next one. F inverse, when X is -4, this answer is just going to be -3. And to me, this is easier because now when I ask you for the y-intercept, I can just look at where does it cross the y-axis. That answer is 3. Again, there's other ways of thinking about this problem. So I'm not going to sit here and tell you you have to do the problem my way. But this is one way of thinking of it. And we already did part C. We graphed it. I do want to point out, though, that you can now write the equation. And I believe you learned this in Algebra 1, how to write an equation by looking at the graph, where, let me give a quick reminder for you. Think of mx plus b. Well, the b stands for your y-intercept. So the y-intercept we just found in part B was 3. And then the slope, that's what m stands for, is up 3, right 2. So y equals 3 halves x plus 3, up 3, right 2. I don't know if I need to clarify that anymore. Yeah, so as we move on to my last exercise, I think it's very helpful to recognize that all we're really doing is switching x and y's around. So if I were to ask you to do this, all I'm asking you to do is switching the ordered pairs. So for -2, I hope you recognize how I'm switching. I'm trying to hurry to keep this somewhat short of a video. I don't want it to be too long. And then for 2. So if I were to graph these ordered pairs, 1, 1, 1, -1, 4, -2, and then 4, 2, what you'll notice is we have this graph that fails the vertical line test. So what do I know about this function's inverse? Well, it is not a function. And thank you for those sticking with me this long. So we can now get to the very last thing. And I started it, I'm going to end it the same way. An inverse only exists if it is 1 to 1. In other words, it must pass the vertical line test and the horizontal line test. Let me go ahead and add in the vertical line test. And then I'm going to hit end on this video.